Thanks to everyone for joining us today. My name's Eugene Shirley. I'm the president of Pando Populous, and I really appreciate you all being here. Pando is an environmental and social impact accelerator. We're based here in Los Angeles County. Our Pando Days initiative is bringing art, design, architecture, and sustainability programs together from about 10 Southland colleges and universities to help LA County implement its new and very ambitious sustainability plan. So each of the participating Pando Days institutions took on a different goal from the county's plan, and they've created very innovative ideas that they brainstormed about in the fall of last year, developed over the last 7 months or so, and have created then project descriptions, implementation plans, renderings, prototypes, what have you, in order to push them to the next step to make the projects real. So today is the first of the 10 Pando Days premier events, and we're beginning with SCI Arc, a Southern California Institute of Architecture. We have scheduled 2 such premier events per week over the next 5 weeks, 1 event for each of the participating schools. So over this period, the projects will be assessed by a panel of judges. There'll be 4 of them. They'll all come together on July 25 to hear their assessments and for a festival finale virtually. I hope you can join as many of the Pando Days premier events as possible over the next 5 weeks and be with us certainly on July 25 because it will be a very special event. The Pando Days host for today is John B. Cobb Jr. John is the founding chair of Pando Populous. He is a great pioneer at the intersection of philosophy, religion, and the environment. He's the author of something like 70 books.
Oh dear.
And he is a member of the American Academy of Arts and Sciences. So, John, with that, I'm turning it over to you.
Okay. Well, this is a great honor to be asked to be the host of the first of these events. And I think that the way in which they're planned is quite remarkable. Each of the events is responding to something in the plan for the county. The rather great plan has been made by the county for what it wants to become in the next 10 years. And the third of its commitments was to become an equitable and sustainable land use and development without displacement. At least that's included in the title of one of these. And the students at this university, SCI Arc, have chosen to highlight from this the particular matter of housing, excuse me, well, I think it can all be housing, but not just housing people, the whole use of the buildings. And this is a huge problem in California, especially in Southern California. It's the problem that comes with being a very attractive place to live. And the more attractive you make it, the more people come, so you'll never catch up. But at least you can be more efficient in your use of land. And they're figuring out ways of doing that, specifically by using technology, and we'll hear much more about that. And I greatly appreciate the vision that these young people have. And this is an immediate vision. The technology is available for implementing to some extent the plan for the county. And if it will be implemented, it will certainly be beneficial to all concerned. The members of the teams, it seems to be a series of teams, and I'm going to try to read this from my source here. The 2 leaders Casey Rem and Minnie Ziegler, and they're professors at the school. Then there is the I Live team, and that's the Soledad Chamorro, Hari Deshpande, Philip Hood, Isabel Scoro, and then the House LA team, Luke Falcone, Zihan Gao, Sadhvi Jayanth, Amanda Koch, probably, Infrastructure Prosthetic Team, Lorenzo Delgado, Felipa Maman, Yash Mehta, Julia Pike, and the ACT team, Jules Benelucia, Jennifer Rufina, Andrew Stone. And finally, there's the Pando expert, Bill Margulis. I would like then to turn over this direction to the leaders, Casey Rem and Minnie Ziegler.
Thank you, John, for the introduction. Good afternoon. My name is Casey Ream. I'm co-leader with Mimi Ziegler of SCI Arc's team in the Pando Day initiative. Together, we led a research-based course of 18 students to identify policy and economic issues impacting housing shortages in Los Angeles County and how artificial intelligence-based software can aid in addressing these issues. The research phase focused on 4 primary issues: equitability, affordability, sustainability, and also are the current strategies for housing reflective of the desires and cultural realities that we live in, or are they more symptomatic of economic imbalance? As the students completed this phase of the research, they've identified the topics they were interested in focusing on. They also worked collectively to build an artificial intelligence-based software platform for exploring them. The platform takes a concrete approach to machine learning models of artificial intelligence to explore their value while also demystifying current technology. The primary focus of this technology in our projects were to improve analytics and to automate design production. The 4 project teams then specifically tailored the platform towards projects related to their findings from the research phase of the course, and also to reflect the goal number 3 of the LA County proposal for equitable, sustainable use and development of land without displacement. In summary, the 4 projects are an incremental housing and brownfield remediation, platform-based accessory dwelling unit development to identify suitable backyards and match homeowners with renters, using AI and automation to develop co-housing for people with disabilities, and 3D printing ADUs on steep sites. At this point, I'd like to turn over the presentation to Philippe, who is a team member of Infrastructure Prosthetic, to give you more specific details about their project.
Thanks, Casey. Hi, everyone. I'm Philippe, and I work with Julia Pike, Lorenzo Vazpinto, and Yash Mehta on this project. We were looking at lowering the cost of entry to developing affordable housing by implementing structural platforms that supported electrical and mechanical infrastructure, as well as partial weatherproofing. And basically, we wanted to tackle all the most expensive pieces of the initial entitlement process to make a housing support system relevant and affordable at a variety of economic scales. And one of our goals was to find ways of repurposing underutilized and environmentally compromised sites in LA County for the development of affordable housing. We focused on sites along the Alameda corridor because the shipping route project ultimately failed to deliver high quality community resources to the lower income residents who live nearby. And it actually created more liquefaction zones along its length, and that led to a subsequent increase in brownfield sites. And we chose to simulate the rehabilitation of one of those sites that was previously zoned for multifamily development with a history of light industrial use. Our project consisted of a modular system of infrastructure prosthetics that attach to and augment the existing city grid. And this is a system that's able to expand to fill sites of any size and shape, while at the same time optimizing their usage of water and energy. And in that way, we aim to offset inefficiencies that would have otherwise required really lengthy policy reform processes to fix. Now, to do all this, we used a form of machine learning called a wave function collapse algorithm, which allowed us to procedurally optimize how a site surface area could be filled with these units and connected to existing infrastructure. The algorithm examines every possible way a site could be filled with a predefined set of modules and distills all those options down to a select few optimal results and allows us to choose at that point. Basically, it divides the site into a grid and fills cells using a given start and end points. And in between the site stubs for water and power and the housing that we designed, our algorithm laid down elevated platforms that would minimize the amount of pipeline required to provide an entire site with water and power. So over the course of the project, we essentially developed a system that could fill a site with a critical density of sustainable residential units, and which are all safe from the ground level hazards of the brownfield site, while at the same time allowing for environmental remediation of that site as a whole. Thank you.
Thanks, Philippe. I'm going to summarize the the other three projects. First is House LA, which is a web-based platform for rethinking traditional landowner-tenant relationships. The platform utilizes artificial intelligence to analyze prospective properties for viability and pair potential landowners and tenants based on housing needs. An online platform allows landowners and tenants to collaboratively design viable housing projects from a catalog of prefabricated parts. This reduces the economic risks of construction for the landowner and ensures adequate housing for tenant needs. The iLive platform it implements artificial intelligence to both automate the adaptive reuse of existing light industrial buildings into accessible co-housing, as well as automate the management of aeroponic microagriculture. The embedding of microagriculture into the prefabricated building components provides additional economic benefits to the inhabitants while simultaneously improving their experiential quality of life. The automated compression tectonics team applied machine learning platform to both site analysis and the automated design of 3D printed structures. The adaptive nature of the software allows for difficult to be developed terrain in Los Angeles to be utilized for housing. Foundations and structural piers are 3D printed on steep sites with minimal excavation, lowering the cost and effort to build on these sites. These projects are initial steps in continuing research at SCI Arc into bringing AI-driven housing into the real world. Moving forward, aspects of these projects will be prototyped using our new AI robotic facilities upon the reopening of the school. Additionally, we are working to integrate our AI tools into more accessible design software to expand their impact on the profession. We are committed to moving these efforts from the speculative to the real to produce real change in the fields of architecture and construction and their impacts on housing in Los Angeles County. Thank you.
I want to introduce the next group of speakers one at a time. The Chief Sustainability Officers of LA County are very interested in the work of these students. And the first one who will be speaking is John Rigo of Sony Pictures.
Yeah, hi, thanks, John. And thanks everybody for presentation. I glanced through the videos and the website you created last night, and very impressive, not only in each concept that was developed, but also in the multifaceted approach that you took to find housing in a variety of different places and variety of different setups across Los Angeles. So really well done. You know, we obviously work a lot in our space around building really from a sustainability standpoint to make sure that it is integrated into both what people are doing on sort of a full life, so where they can live and work in close proximity. And I saw that in a couple designs. A lot of what I think we saw was a dependency on AI and the neural networks, which I think is fantastic. Would like to ask the group a question around that issue, and you know, the AI tools, although I'm not an expert, we've used them in our company a couple times, really around music and entertainment, are only as good as the training of that AI tool and the patterns that they see at the outset. So I'm curious, with all four projects really having AI at the center of determining the locations or potentially even the design. How have you guys developed those AI tools? Have there been real life models that you've used to help identify those patterns, or who created the patterns that was fed in to the logic that
Yeah, I mean, I think that, those are very good questions. And I'm pretty sure that when the students signed up for the course, they didn't realize what the embodied labor of developing an adequate data set for training was for these networks. There's a couple of different strategies we used in terms of some of the shortcomings of this. Like one was just not overstepping like our belief in what the networks could achieve, like identifying the areas that they excel at, which is, you know, largely pattern recognition. And automating existing patterns, right? Which leads to some issues around a concept called inductive stagnation, which is that the machines tend to repeat the pre-existing solutions. So neural networks were just one component of the platforms that we worked with. Other forms of like intelligent agency, more explicitly coded solutions were introduced into them. But a big portion of the project were the students manually designing the data sets that they trained from. And certainly I would say at this point in the course, none of our platforms are, you know, would we be willing to stand behind as saying like, this is a perfectly viable solution. They're all things that are on the way to that. So that definitely more research into development of the data sets for producing kind of value for improving these projects is part of the ongoing process we're looking at.
Yeah, and just to add just quickly to that, the students, if it wasn't clear, the students in many cases taught the AI themselves through recognizing, say, the adequate warehouse footprints or the size needed for a backyard ADU. So there was some real hand labor involved in this.
Fantastic. Just thinking of, you know, again, and maybe I'm not correct of saying that sort of the AI sort of underpins a lot of the site selection and design that came out of it. You know, thinking about this as sort of a next step, and curious what the students would say. How do you get that AI to be something that you could have more confidence in?
I mean, maybe Philippe can expand on this, but I think one of the things that we want to get into and why it's so critical for us to move into the physical prototyping phase is to validate the models. There's really no way of validating except by trying to compare against like kind of existing performance, but then actually rolling things out and testing them explicitly.
Great.
Yeah, at least in our project, there was a component of testing it against manually designed versions of the thing to just gut check ourselves.
Yeah, like things that are easily quantifiable, like square footage of green space and those sorts of numbers. Those things are easy to kind of test against. Yeah.
Perfect. And yeah, I mean, I can keep asking questions, John, but I think I know other people want to jump in as well. So I'll wait until a little later and then continue.
There's spot on questions there. Thank you.
The next questioner is Austin Erickson from CSUN, Northridge, I think.
You are correct. Yeah, no, I mean, this overall is a very interesting project. Definitely a whole new way of thinking about how to access a unusable or even unknown land, right? So I was watching the video yesterday of the land that was next to staircases, right? You know, that would have previously and probably has continued to be thought of as unusable, right? But when you start thinking about 3D printing a building, it makes things all of a sudden much more feasible. It sounded like there was a few of those buildings that have already been done. I was completely unaware of that, to be honest, but very, very interesting. And I think that, you know, there is a movement, I think, towards tiny homes, right? And I think the ADUs in people's backyards is something that we are going to see a lot more of in the future. And I mean, it's already happening, but not in this type of modular concept where, you know, it almost looked like it was all pre-built, right? And you're dropping it off at someone's house and it gets assembled relatively quickly. So I mean, overall, I think the whole concept was very interesting on all 3 or 4 of the projects. I did have a few questions for the teams. So from an adoptability standpoint, do you envision do you envision any challenges with people putting ADUs on their property? I mean, is there a reason that hasn't taken off yet, or why do we think this is a solution to that?
Well, I think one of the teams, the LA Home team addresses this. One of the biggest issues with the adoption of ADUs within LA County is actually the permitting process. And so a lot of homeowners can't, get caught up within that, and it slows down actually the ability to densify neighborhoods with the use of ADUs. And so I think with this group, they were also strategically looking at how a kind of third-party platform might be able to wholesale, go through a permitting process, and in a way take the homeowner and the renter sort of out of that process in order to expedite it.
Gotcha.
I think also along those lines, several of the projects that we're looking at the kind of automated design process, currently there are some really good products out there for prefabricated ADUs. Generally their cost is higher than traditional construction, but the flip side is if you're doing traditional construction on site, you're looking at having a construction team in your backyard for 6 months to a year, which deters some people from pursuing it. So one of the things we're trying to use the platform for is bringing down the cost of prefabricated solutions to be closer to standard construction, but have those kind of ideal prefab 1 week on site kind of timelines.
Interesting.
Can I ask a follow-up question to that around the ADUs? I mean, I think one of the general comments I have, both from reviewing everything last night and as well as today, was everything went very fast. There wasn't a huge amount of detail built into the overarching vision and picture, and the overarching vision and picture I think is really great, and especially the fact that you have 4 pieces of things that can really help us across LA County around housing. But detail is pretty thin on everything. So for the ADU units, right? So part of it is above ground, part of it is back to what you had some of those other areas, infrastructure. How do you envision resolving all the issues around infrastructure, which is often a sizable amount of the costs when you're putting in an ADU unit? You can four walls and running some electrical wire, I think most of us on the phone could do if we really want to spend the time to do it. A lot of the other infrastructure is a lot harder and specialized. So how does that?
Yeah, I mean, I think specifically in the team that was looking at the backyard development for the House LA project, one of the things that our model for analyzing viability for ADU placement is identifying sites which have easy access to the utility stubs from the city. Because you're right, that is a big issue. And that would be, a sizable part of the construction. So in addition to doing things that are easily quantified, like site setbacks, FAR, those types of code related things that specify the dimension of the buildings, we were trying to build in the model additional things that would be cost prohibitive, like excessively difficult hookup to infrastructure, or even things like having really large trees that would need to be torn down, right? So the model hopefully would be able to identify and quantify for the homeowner what the actual cost of doing that sorts of thing is.
And is that data readily available?
It is, but it's not formatted. So a huge part of the labor for the group is trying to get all of this information standardized in a way that we can implement in our model.
Philip, do you want to talk a little bit about infrastructure as well in your project?
Yeah, I was about to say that question is pretty much the central thing behind our thinking. We wanted to bring the infrastructure to the site in order to circumvent that very issue. And it might not work quite as well at the scale of a single family home, but on a larger plot for a multifamily unit, it does offset both the cost and the expertise needed to install such a thing.
And can you just go into a little more detail of that? I think I understood what it was. You're pre-planning in essence the infrastructure across a larger footprint
Yeah, we're developing essentially the most efficient way of filling a site with a platform that could support future housing development. And that platform comes with all the piping and electrical infrastructure that you would need to support pretty much any type of development on top of that. So if it needs to be the size of an ADU, it could be. If it needs to be the size of, you know, a 20,000 square foot facility, it could be as well.
Their project stems from a type of housing called incremental housing, where sort of basic site infrastructure is provided, and then basically half a house, and then the owner can then build out the rest of the house. So as part of the course, we also did a crash course in different types of affordable housing types, and so that this one is kind of taking this idea of incremental housing and sort of enmeshing it with the AI network.
Thank you, Mimi.
Great. Sorry to steal the microphone.
No.
Go.
No, these are great.
Good questions. I mean, the other thing to think about too, right, is there is a limit on the grid, right? And that, I don't know how or if that's something that you evaluated. So, I mean, the reuse, the use of renewables on these modular type homes would probably be something you want to consider too. I know we're at Cal State Northridge, right? And we need to tell the utility company every time we throw a new EV charger on site, right? And that's how taxed some of the systems are. So I think that's something to think about as well. I don't know if that was a thought in the project.
Mm-hmm. Yeah, I mean, I think most of the projects feature some sort of renewable energy production as part of their component packages for the specifically the ADU package and the brownfield package that Philippe worked on.
Yeah. Within our project, there was also sort of a redistribution component that came with the platform.
Let's let Marc Spears get in on this also. Okay?
All right, I'm done. I'm gonna be quiet.
It is all
you
good.
don't need to be done. I think that it just becomes cumulative. That now we have 3 of you.
Well, let's think of this as a family. We're not ganging up on anyone here. 3 questions. The first one, perhaps for Casey and Mimi, and just interested in the ideation process that led to these 4 projects identified.
I think the way that we approached this course, which was from December to April, is we started the course with really thinking through the different types of housing models that were out there, from prefab to multi-unit, from the good, the bad to the ugly, and really identifying sort of where the systems were in these models. But also looking at who they were serving, where is equity, and how can we better include a larger range of people within sort of the affordable housing premise. Some of that thinking sort of would eventually lead to the I Live project, which is looking at very closely at the policy around affordable housing, and also sort of where are the possible resources for funding, and sort of looking at the people with disabilities as a core group that could really use a sort of a new model for how they live. So ideation-wise, yes, it was really looking at some of the big sort of crucial issues to housing, and then introducing AI, talking through very carefully the kinds of questions that came up around how they detect patterns, but also the kind of inherent bias, which we very famously can be within AI, and then using those 2 in combination to generate the ideas. The students worked in teams, as you see, and they are really responsible for sort of the unique courses that each one of these 4 projects takes.
Yeah, no, fantastic. Maybe just building on the last comment about bias, because it was one of my questions regarding House LA. So when we look at the matching of landlords and tenants, how are we protecting against that matching bias as it relates to gender, ethnicity, what have you, and some of the challenges that I think AI currently presents? Sure.
I mean, I think I'm also to the question about how everything's very general right now. Like on the website, there's a position paper section. We will try to continually update those papers with more of the kind of more detailed findings, because obviously we're kind of glossing over a lot in these presentations of the work the students have done. Specifically within that project, this is a very central problem. And we were looking at trying to identify basically things that were like purely quantifiable. You know, like we started out with like housing requirements in terms of like family size. But as immediately as you get into that territory, the questions, I think actually something that a lot of the AI research has exposed is that there are underlying patterns of inequality in data sets, even where we might be blind to those. So I wouldn't say, you know, this is an ongoing project to think about, and I think the only way that we can really find those kind of underlying patterns is by testing it, evaluating where our shortcomings are, and trying to kind of rethink the data set to go along with it.
Thank you. And the last one, perhaps for Philippe, on the infrastructure prosthetics project. On one hand, we're remediating brownfield land, which is obviously something that needs to happen, particularly here in Southern California. The other question I have, though, is we're also potentially creating an environmental footprint that replaces it in a different way. I'm just thinking, how did you think about the design perspective from either a net zero or net positive perspective when we're thinking about energy, waste, water, et cetera?
At least from our perspective, that was mostly in filtering the way that energy was used on the site. So making sure that each individual module connected to every other one in the most efficient manner possible. Beyond that, as Casey said, it's a developing project. And
Got it. All right. Well, thank you. Thank you. Wonderful projects. And also, I think the beauty of these projects is that they sense like they're commercially viable now.
Casey, did you want to note just the potential of sorry, I'm having a brain moment, of using SIPs that are out of recycled materials as part of the next step?
Oh yeah, so there is a larger research project at SCI Arc that we were undergoing, looking at using scrap timbers to produce robotically assembled SIPs, or structurally insulated panels, or other kind of prefabricated panel systems. So a lot of the renderings you see or in the videos have a kind of wood textured thing, which are implementing those sorts of panels. The idea is bringing some of the technologies from CLT, which are currently targeted for, that's cross-laminated timber, which is a construction product targeted to replace steel and concrete currently, into lighter weight implementations where we would be using a kind of similar strategy, but allowing us to implement scrap timbers from the lumber process.
Excellent. John, I'll turn it back to you, or to Eugene, or?
Well, I'm going to turn it immediately over to Adam Ewens, who's going to moderate a discussion that is open to everybody, I understand.
Hi, this is Adam. Am I unmuted? Yeah.
Yeah.
Well, this was already a beautiful discussion going, so riveting between CSOs and SCI Arc. So if any of the people online right now have questions, please put them in the chat box. I do have a question here from Gina, which Casey went on to answer, but I'll read it out loud and see what else you would like to expand upon. Gina asks, would the infrastructure analysis include water, gas, electric in AI's ability to identify sites? Who would create that database? For example, many properties can build ADU do not have access to property site plan or architectural plan because it was not required or was not saved in the city database.
Yeah, so I mean, the first part, the first sentence up to the question mark, that's pretty easy. That's all publicly available information. That's actually things that you would integrate in the model without even relying on the neural network, because those are all kind of directly quantifiable values. To the second question, and this is where it starts to become more difficult and where we think that the neural net may allow us some benefit, is its ability to kind of interpret information from what appears to us to be underdefined data sets. So if we correctly train a network on properties that have the sufficient information from it, ideally the network would then be able to interpolate those gaps in our information from what we are able to show it. That's kind of where the real value of a neural network is being able to kind of interpolate or correlate data at a level of resolution that we wouldn't be able to without it. So even if we don't have all of the adequate architectural plans, the hope is that the machine would be able to kind of fill those gaps based on what it can see.
What does the prototype actually look like? Is it like a Google search engine, a MS-DOS entry window?
Yes, the last one. Yes, yeah. It's a Python terminal, which looks like the old MS-DOS terminal. So it's not, this was, you know, as I was saying, we're looking to integrate this more seamlessly into kind of more commercially available design platforms so that you don't need to open up a scary kind of black text-only terminal to work with these types of models.
But your students had to learn a certain kind of coding?
Yep.
And do you see that as a requirement for the future architect, that they should be able to speak a software language?
I think it certainly gives architects greater agency moving forward, and basically being able to shape the kind of direction of the practice and the profession. Additionally, we're seeing other kind of corporations or entities starting to get into the kind of building world. Like a good example is Katara up in San Francisco, which is coming from a platform side and looking at vertically integrated construction. You know, they're coming into this territory that we call architecture from a completely different perspective. And I think that as architects, in order to maintain the viability of our profession, we also need to be able to like fluently dialogue with these types of companies and corporations. So certainly within the program Philip is in, which is one that I work with closely, like every student has some competency with programming by the time they graduate.
There's also been a big shift towards visual scripting, which is sort of a node-based metaphor for programming that makes this type of thinking a lot more accessible. And so it seems like it's going that way to begin with.
How radically innovative is this class in the field of architecture? Are all universities looking at this right now, or?
There's a handful of universities looking at these types of technology. I mean, even within SCI Arc, I think that this class was a first for us and one that we're very excited about, because this is the first time that we've asked students in the same class to do very thorough policy research at the same time as trying to develop an active prototype for a platform. So linking those two things together in the same class kind of takes it out of the realm of pure experimental research and speculation, something which has a more direct impact on the profession.
And that policy part was not what you brought as an architect, that's what Mimi brought as the kind of more theorist, writer, curator. Mimi, how was your experience in working at this technological frontier?
Well, I think I really want to give a lot of credit to the students and to Casey, who really guided them through this. For me, I think bringing together these two elements, which might seem like an experiment, is so useful, because taking something from abstraction and bringing it into sort of the discussion of real world conditions is so important. You know, one of the texts that we used within this class is The Color of Law, which talks about the history of racial discrimination within housing policy and city development. And so the students are kind of going into AI with a kind of background in sort of what is really on the ground at stakes. And as we see it right now in our present moment, these are conditions that are not abstract.
Casey, you mentioned that a logical next step of development would have been creating actual physical prototypes. What else is it what else is needed to bring this from the speculative into reality, into something that the LA sustainability plan could apply to reach their goals and strategies and actions?
I mean, there's a few things like I saw, and also maybe this ties into a question I just saw by Marc Spears in the chat. One of the things is setting up the appropriate material infrastructure for this. This is something that, like it was locally. So for example, in the CLT project we're talking about, this is a project that's emerged with the discussion of a company which is one of the larger wood supply companies in the US. That's still ongoing, but the idea is to look at like what would actually look like for them to set up a factory to produce the materials that we would need locally, and have a distributed set of factories that could use this kind of platform so that you don't have to build one factory and ship everything, but you could build smaller factories with some aspect of automation to many different regions. The other one is, I mean, I think the biggest hurdle in terms of making these models fully viable is the massive amount of labor necessary to make robust data sets and validate them, as we were talking about. Our students did an excellent job of putting together the information that they could. I think you'll notice things like the House LA targeted a specific neighborhood in the Valley because that was where we could get a really clean data set. And it was localized and focused enough that they could build something viable for something at that scale. So scaling that up to something that is generalizable would require a pretty significant investment of time and effort.
And would that be within the walls of academia, or would that need to move to something more like an incubator or post-academic work?
Yeah, I mean, that could take place at a couple of different levels. I mean, it could even be a public project to kind of work. I mean, this is something that, most cities wouldn't have a budget for, but finding ways of doing things like correlating all of the available public information, which is already hosted by the city of LA, for example, into a format that's standardized so that people could leverage it for projects like this more quickly. But it also could be something where, in an incubator, you have a team developing these sorts of data sets or manually going through and correlating it. Just because the kind of scalar reference, the House LA team made a data set of 5,000 sites. And we're looking at needing closer to 100 and across a varying range of conditions to make the model robust enough to kind of analyze more than just a kind of suburban area.
Philip, are you planning to move your career in this direction?
There's a lot of plans out there. There is a fellowship position that SCI Arc has just started for people coming out of my degree. So that would be an opportunity to continue this project work.
Okay. John Rigo has a few questions that he typed here. Would you like to ask those yourself, John?
Yeah, thanks, Adam. Yeah, I was just again, I can't express what a great job this is, and I personally haven't seen sort of an architectural design paired with AI in as collaborative a way. So well done on that. So my question is, when the information, as you're going through this project and you were looking at these locations that were determined to be applicable for the use, did any other concerns come up with the use of that location and the use that you're trying to put at that place? I'll leave it vague there. I have some thoughts in my mind, but I'd be curious to what the group would come up with as potential risks or red flags that might be needed to, in some ways, make the data set or the AI tool even better.
Yeah, I mean, at least for our project, that we used GIS systems to help our identification of viable sites. Just as Casey said, if we scope this too large, the AI wouldn't really be able to help us quite so much. So we limited it to sites with the highest possible walkability score, with less than a kilometer proximity to public transit, with at least 2 major hospitals and minor health facilities surrounding them, as well as public schools and all the other, because we're trying to establish the beginnings of a culturally supportive system, not just residential development. So we wanted to limit our scope. It would have been too much to take on all of those as operational variables in the time we had. But as we go on, those would be variables that we would sequentially bring in as we figured out how to quantify them more effectively.
And the I Live group was looking at industrial warehouse buildings, which were in neighborhoods of transition, with the idea that they would build equity into those sites by basically investing in warehouse sites with the sense that they are close to transportation and would ultimately begin to develop kind of like in and around the Arts District and sort of other downtown sites. So in a way, they're able to sort of kind of position early the work in a context which could pay off over time.
I think it's time for us to wrap up this section. Thank you all so much for your questions and answers, and I'll turn it back to John Cobb, please.
Well, I'm very impressed by what all of you are doing and saying. I can't say I really understand it all. It's not that I don't understand most of the words, but you are dealing with issues that I just don't know enough about. But you were talking about one topic that's very dear to my heart, and that is I'm very unhappy with higher education because it has put so much emphasis on research in narrow compartments that it is really not able to deal with the major issues of the world. And people don't get even individual courses like this that actually are designed to be relevant to the urgent needs of real people and real institutions in the world. I think that it's happening more at the course level. Oh, was I muted that whole time?
We can hear you.
You could hear me. Oh,
yep.
That was a sign I don't understand all this. As you can see, I illustrate my claim to be ignorant about AI. But the academic situation, I think, is changing. The academic situation we have faced in the past decades is well reflected in the title of a very influential book, which is entitled Save the World in Your Own Time. It meant that the professor was not hired by a university to do anything relevant to saving the world. The university professor is hired to do research in narrow channels, largely determined by the interests of people who provide money for research. And unfortunately, the world is not able to provide that kind of money, so it gets neglected very seriously. But I'm just delighted with this course. I've seen individual courses elsewhere. Let me say, I hope that you move forward from the great learning experience that students have when they are really responding to concerns of the society in which they live and doing creative work of that kind, and say, well, you know, you could give a whole degree on that. You could plan a degree so that the student was really making a contribution through the whole program. I believe that's going to happen. In my view, higher education should be about solving the real world problems and not simply about advancing fractionalized research in topics that may or may not have relevance or valuable relevance. Some of them have very destructive relevance. So it's been a great honor to me to preside over or to be host of an event which is about topics of which I am almost totally ignorant, and then discover that I do appreciate its real importance, not just for what actually happens in the county, but for what actually happens in universities. So thank you very much. And I will return this to Eugene, who is the master of something. And when I saw the schedule and that we had less than an hour to do it, I was amazed. But it's happening. So Eugene, congratulations on that too.
So the challenge is now mine not to go on any longer, which I promise I won't. Thank you so much, John, for serving as host for this. Thank you to the SCI Arc team. It's really a fascinating project, extremely interesting, and enormous potential, I think, surely. So thank you so much. Everyone, remember that you can see the SCI Arc project on the pandopopulous.com website. Just go there and you'll see Pando Days and click through and you'll find it. Thanks so much to the CSOs, to John Rigo, to Austin Erickson, and Marc Spears for their responses. Also, Marc has been key in helping brainstorm this whole initiative from the very beginning. I have to say many thanks to the Pando Days team. I'll mention right now, curator Adam Ewens, producers Shelley Goldstein and Betsy Hunter, and story coach Judith Parker. Let me just say, Pando Days was conceived with the help of the CSO Strategic Task Force, made possible by the Conrad N. Hilton Foundation, Second Home, the Mary Knowles Sisters, and many others. Make sure to join us this Friday at 1 o'clock for the premiere presentation by LA Trade Tech Architecture, their new initiative called Repurposing Land. And it is also up now on our website. And so you could take a preliminary look at that if you want to. Projects are going up, just to remind you, on the website on a rolling basis. And so they are posted on the Friday before their premiere week, and they'll be premiering over the next 5 weeks. Thank you all again so much for joining us and for being a part of this. And I hope to see you this coming Friday at 1 o'clock. Have a great afternoon. Thanks again.
Thank you.
Thank you.
Thank you.